Okay. Let me tell a couple of words about myself. I use Python for more than 16 years. I'm a pretty old guy, looks like. I'm a Python core developer, so it means I'm a committer into CPython project. I helped Equida to create asyncio. Now my main spare time duty is maintaining aiohttp library, which I will talk about right now, and support a dozen of other asyncio based mostly libraries under iolibs umbrella. Iolibs this is GitHub organization for all my open source work, and I am not the only single contributor, maintainer, but it's really a community. So please raise your hand if you heard about asyncio or used it. Wow. More than I expected. Raise your hand if you use aiohttp somehow. Oh, good. Okay. And raise hand if you used or use now Tornado or Twisted or Jevent, any async library. Good. So, why do you need asynchronous code? The question is easy. Let's assume we have a modern architecture with front-end side, which communicates with other microservices or external sources like GitHub or Facebook, and collect data altogether and send back to client. With traditional synchronous approach, it should wait for answer one by one, and moreover, it spends a significant amount of time just in waiting. To solve this problem, you can run multiple threads, but you have the limitation in total amounts of thread in your host system. With asynchronous, you can do much more. About 1,000 or couple thousands native threads for application for process. It's reasonably higher amount, but with asyncio you can support billion lightweight threads in parallel without any problems. Okay. As aiohttp this is an asyncio based approach for web. It contains client API and server API. Supports persistent connections, known as KPIs. So, it has native WebSocket supports and much more. The library now has 3 years long story. At the very beginning, it was part of asyncio itself, part of Tulip, but later was extracted because asyncio is not frozen, but asyncio development architecturally finished. It's now stable and good enough to be part of Python itself, to be pushed in batteries. But aiohttp is changed much faster than Python itself. We don't want to wait year and a half until next release. We release often, and this is the main reason why we have separate library. 22 release. The next release will be 1.0. We decided to declare we are stable enough. That's good. They have big enough community and good code quality. 98% code coverage. It's not bad. I'll start from the client API because it's easy. I believe everybody know what request library is. With requests, you can do web page fetching in code like this, 3 lines of code actually, pretty easy and straightforward. How to do it with HTTP? Right now, answer is no, you should not. Technically, HTTP support very close solution to request code from previous slide, but this way was deprecated half year ago because in practice better to use sessions. Session is an encapsulation for both cookie storage and connection pool. So session is like a window in your browser. If you open your site, cookies are saved between going between different web pages. Session does the same, and also session may improve performance for free because session internally has connection pool, and if server support keep alive, session will not close socket and not reopen the socket every time if you perform access to the same web server. So preferred way is using session. Simple way will be resurrected in aiohttp later after spending deprecation period, removing function, and reinvited the functions with different API, different meaning. Okay. Sorry. How to work with sessions in aiohttp way? Like this. You have create session, use async with construction. It's like with, but allows to do asynchronous IO input output in entering into context and exiting from context. Basically, it means using async with Python will do a resource cleanup, close sockets, release memory, and do other things. So with client session, we do session ahead up like this, very close to requests usage. Get response back, analyze status and headers, and ask for the response body. Await is an analog for just plain regular function call, but text is coroutine function, and we should wait for coroutine finishing. Just
Go ahead. Go ahead.
I can take it in my head. No?
Oh, you should hold it.
Yeah, no problem. Okay. So, what to do with coroutines? Coroutine is async def function. It means you can do asynchronous I/O inside. You shouldn't care too much about coroutine, but keep in mind two simple rules. Coroutine is async def. Coroutine with await, like here. Sleep is coroutine, so you should put await before call. And if your function contains await, like this or this, you should convert this function into coroutine also. Make it async def. It's like asynchronous poisoning. If your code has awaits and coroutines bubble up to very main function. Just very close to classic synchronous approach, but a little bit different. Now we will create multiple tasks. Create task is something like a lightweight thread, but in async I/O. We create many tasks for fetch raw resources, wait for all of them, and this is pretty straightforward code. In result, we will get two response bodies. In classic synchronous approach, you see, we have three tasks. In tasks executed sequentially, one by one. In thread pool approach, we have three threads, but gray parts means thread is inactive. Because in Python, GIL exists, global interpreter lock, which allows only one thread actually be executed at the same time. All system may wait for some I/O, and we use our CPUs, not CPU times, not very effective. Switch between native threads also. Not very cheap operation. In async way, we interleave our parallel task executions in the same main thread. And if our task is I/O bound, it's very effective. Next, timeouts. In real world, you need to use timeouts for almost any I/O call, because server might be down, because bridge gateway might go away without notifications, and in reality, the only stable, consistent way to be informed about problems on the wire is waiting for operation with some reasonable timeout. The easiest way is to use just this statement. It works. WebSockets. And another slide. To use WebSockets instead of client get or client post, use VS connect, connecting to WebSocket endpoint, and asynchronously iterate our messages sent by server, WebSocket messages, analyze data, answer back, close when you need. The code is very similar to classic synchronous way, but it's asynchronous internally. So next topic is server. I believe everybody know Django or Flask or another classic WSGI framework. This is an example of Jenga, very simple site. We have index view which accept requests, returns response, and we have URL patterns to describe where what is passed to our index page. In aiohttp, we'll do almost the same. We have asynchronous view. This is async dev. We can do some I/O inside in asynchronous way. Return response, create application, register our view, our web handler under /pass and run application. That's it. Tornado, another popular network, use completely different approach. You should derive from some base class, override get or post functions, and do write code here. It works. It looks like maybe class-based views, but I believe code like aiohttp is much more familiar to casual developers. It looks more clean and maybe more handy. But aiohttp supports class-based use also, by the way. So WebSockets, server side support WebSockets too. We create special response class. We prepare it, establish connections, does handshake procedure and so on. And after prepare finished, we can iterate our messages, and this code looks pretty close to client part. I think it's good. A couple tricks and suggestions about effective development, or maybe another things like testing and so on. In development, I suggest use the single process with single thread for running your test server, to run your staging server. In reality, in production, you may want to utilize multi-core processor and run as many processes as your server has. That's good, but for development, much easier to do everything in the same thread. HTTP and asyncio allows it, fortunately. But for deployment, you just write different startup code, couple lines, and start many processes under unicorn or manually, up to you, using upstart scripts. You usually don't need message queues. No salary or Redis MQ, other things. Just because in any point of code, you can easily create new task, start new parallel lightweight thread, and do some long work in parallel. What long work can be? Just classic examples for salary. It's sending emails, communicating with other clients, and so on. Debugging. Let's see. This snippet describes the problem. We have a future object. We have an exception in future and delete future without asking for a result. Future has a guard which will not raise but report about error, just print out it in logs. Future finished with exception but never retried. It's usually a sign of something bad in your program. But you don't know what future is, where it was created. Usually your program has many futures, thousands. With this flag, Python asyncio debug should be something non-empty value. Report source traceback is attached to report, and you see what line of code created a future, and also it enables many a lot of useful additional debug information. And I suggest to run your code while you develop with asyncio debug enabled. But everything has its own price. Debug mode slows down your application, so it's not for production, but very useful for development. What else? Explicit loop. It's very painful point, unfortunately. Asyncio has an implicit default event loop. And if you don't pass event loop into asyncio API, the same rule is true for aiohttp. Global default event loop will be used. It looks very handy. You shouldn't pass loop everywhere, but your code is non-test friendly at least. I suggest to pass loop everywhere explicitly and disable default event loop by this line, and very beginning of your application to make sure all API will share explicitly passed loop. Trust me, it's not very hard to pass loop everywhere, but it helps to avoid some strange problems. Keep alives. I told about keep alives before. Usually you need don't need to create new session for every request. You need maybe single client session for the whole program, and just use it for sending requests, because session creation, session deletion costs something. It's cheap but not free, and if you share the single session between all your code, you can share connection pool. It's good. Testing. I believe everybody knows and does unit tests in test-based development. With asyncio, there is a trick. Test function should be just a regular function. It cannot be async def function. Just because standard Python test suite does support coroutines in this place. So what should we do? We can create internal coroutine, perform all code, put all code here, and run this coroutine, waiting for coroutine finished. It converts our asynchronous code into synchronous classic test. Looks not very handy. You can easily write decorator for this test function, or my preferred approach, just switch to PyTest, install PyTest aiohttp plugin, which will automatically, magically run async dev tests. This is my choice for last years. Next problem. Global objects. HTTP designed to not require global objects at all. It has no global objects, and user shouldn't do it. See, we have a motor client. It's MongoDB asynchronous client. And we have a synchronous connection to database, and then ask for some user, find user by login. What's wrong with this code? It's not testable because for every test, it's very good idea, very useful practice to run every test in own separate loop. Create a new loop before test starting and close loop test finish. The reason is very simple. If you will share the same loop between all your tests, first test may start some task, create lightweight thread, and quickly finish successfully. Next test will go, pass, and on, I don't know, 15th test, task created by very first test will fail. And you have no idea what's going on. Your tests are not separated, not isolated. To isolate test, you should use a new loop for every test. But our database, this DB object, actually use implicit loop and ask asyncio loop on creation and store it inside the database. So it starts connection and so on. But when we create new loop, close previous one and create new loop, database is not aware about default loop changing and asking for some data, perform await user's file, for example, will hang because loop coupled with Mongo client closed and it will never be iterated again. So we will wait forever. What to do? That's easy. Request has application property. It's web application object. Application object itself is dict. Dict is good storage for application global namespace. So we'll use database key for accessing to our MongoDB client. And this is initialization, classic initialization steps. Create MongoDB client, store it into application object, and register cleanup signal on application closing. Cleanup processors will be executed, and we have a place for graceful shutdown. It's very handy. So we have no global clients at all, and in my programs I have no need for globals. It's cool actually. No one singleton. Sorry. Middlewares. Middlewares is another interesting technique. If you use Jenga, I'm pretty sure you're aware about middlewares. It looks like onion. A request goes not directly to web handler, but passed before execution through every middleware. Middleware may modify request, do some things, and going back, response are passed to middlewares in reverse order. So you may modify response. Why do you need this? For many reasons. Authentication, for example. Middleware may check user credentials. Middleware may use sessions, store sessions on exit, like in this example. We have a separate library called aiohttp session. It's a third-party library based on aiohttp, and the purpose of the library is working with user sessions. So we have a session, we acquire it, we modify it, but never save. Session saving will be performed on exit from our web handler by session middleware. Middleware installed on application starting. Another interesting example is very rich and heavy middleware called the Bottlebar. Every network library like to have the Bottlebar. It's just backdoor into your app, allowing to look on requests, responses. This is an example for interactive session. You can type something here in the console, execute the results, and do very many interesting things. And the Bottlebar collects data about activity by installing middleware, tracking incoming requests, tracking responses, and this is the main the main point for collecting data. You can use middlewares for committing database transaction on request exit and so on. So I finished actually. We have time for questions. If you have any. That's it. No questions? Okay.
I wonder the most hardest thing when I use the asynchronous libraries is to follow control flows.
앞에 나가서 말씀하셔서 질문하시면
Yeah, my name is Sul, and I think the most hardest thing is when I use the asynchronous I/O libraries is to follow the control flows between colon and colon, right? And do you have any recommendation about a way to follow more intuitively between colon and colon?
Between what?
Colon and colon and callback, and which function is called by asynchronous and await and some that kind of questions and more. I think the huge code base is to follow
how to convert from existing synchronous to async and how to mix. It's not easy. Sure, in theory you can rewrite all code, but it's not practical solution, right? You can start rewriting part of functionality and run it on different port in different process and covered by Nginx configuration to hide port difference, you know, to proxy different requests to different process. And I don't know another solution.
And I have another question for that. I think some lambda functions or callback functions is, I think, more intuitive than the result was like async or await. Then I think the async IO library developers is much more preferred than the functional compositionality. Then they more prefer functional than they much more prefer the result for async or await than the functional compositionality. Then do you have any idea about why the developers much prefer than wait?
I'm not sure I understand your question, sorry. Can you maybe rephrase it?
I think the functional compositionality, which is like the callback functions or the lambda function is much more intuitive than
Yes.
without more.
In your code, I see no reason why you need to use callbacks. Callbacks is for a very deep level. Actually, Async IO is based on callbacks, but it's low level layer. All high level layers, which casual developer use, has no any callbacks. So I think dev coroutines are preferred way to write your programs. And Async IO itself and libraries like, I don't know, IOPG driver for Postgres, driver for MySQL, driver for Redis, hides callback inside. You usually just use awaits and that's it. No questions? Looks like we finished. Huh? That's all.
The last time I checked the aiohttp, the HTTP to support the HTTP is only progress. Is it only progress, or when do you expect to improve this table?
aiohttp, it's not standard. It will never be probably part of Python standard library. It's third-party project. I told about reasons we develop it actively, but it's stable from in terms of API stability. We have a policy about stability. We don't don't change API without deprecation. After declaring some API deprecated, we will support it for a year and a half. It's enough time for switching to alternative for new approach. So I believe you can use it without big surprises. And that's it.
So you mean HTTP to implement HTTP?
HTTP 2?
Yeah, HTTP 2.
Sorry. Yes, we have requests about HTTP 2. And it's not implemented right now, but probably I'll do it in a couple months. It's next big stone in HTTP life cycle. Wait a bit. So That's all what I can say. But yes, we will do it. We will support HTTP2 maybe up to end of year or something like this.
I have one more question. If I remember correctly, the early implementation of Tulip and support for HTTP2 and HTTP was basically support for HTTP duplicated in Async and is separated project. Is it right?
I again looks like not understand you clean.
I mean, the early implementation of Tulip project.
Yes,
Support for HTTP, right?
Tulip. In Tulip or what?
Yeah, Tulip.
It's that well, Tulip rename it in asyncio included into Python itself, and HTTP support from Tulip was extracted, and now it's called aiohttp. Yes.
So I like to know why it's extracted because it's used to Python.
Because we changed the library too fast, much faster than Python itself does. You know, Python, every Python new release requires a year and a half. It's very long time. We improve HTTP much faster. We release in couple months. So this is the main reason why HTTP is not included. Also, HTTP works, but I want to rewrite deep internal implementation details not visible to user to make it faster, and it's again sign of some I don't know, not maturity, a sign of the library is not stabilized. It's not frozen. We need release faster.
Can you introduce the use case? I mean, is there any company who already use aiohttp in production for large scale? Or some other process project already using aiohttp?
Well, KeepSafe, which initially developed HTTP to use it for sure. Facebook use for small, for infrastructure projects, for support. I aware about companies, Russian companies like Rambler. It's big portal which use HTTP as front server. Grammar problem.
QA time is 3 minutes limited, so you can't go to OS rooms to discuss.
Okay. So I don't collect statistics explicitly, but I know people use it in big projects with big load, and it works. Sorry.
Yeah, we
are run out of time, so.
예, 지금 QA 타임 끝났고요. 3분인데 지금 조금 더 오버가 됐어요. 만약에 궁금하신 점 있으시면 밴드를 잡으시고 OS로 올라가셔서 디스커스 하시면 되겠습니다. 네.
Thank you.